In this video, we're going to look at factors affecting the speed of reaction. We're going to talk about energy being absorbed and released into the environment. We're going to look at the factors that affect the speed of reaction, including temperature, surface area, as well as catalysts or enzymes. The direction in which a chemical reaction occurs depends on how stable the reactants and products are. Now, we always want to move from a less stable to a more stable state, so the products are going to be more stable than the reactants of a reaction. To get to this state of stability, the reaction may either release energy in an exothermic reaction, such as combustion or the acid-metal reaction, or absorb energy from the environment in an endothermic reaction, such as the acid-carbonate reaction. There are three main factors that affect the speed a reaction occurs. The first one is temperature, and increasing the temperature will increase the speed the reaction occurs. The reason for this is increasing temperature causes the molecules in the substance to vibrate faster. This faster vibration leads to more collisions between the reactants and therefore more reactions occurring. Another way to increase the speed of reaction is to increase the surface area of the reactants. By increasing the surface area, we have more of the reactants in contact with each other, therefore more reactions are able to occur. One way of increasing surface area is to use smaller pieces of something. So if you think about a solid, it has a particular surface area. If you break that solid into two smaller pieces, they're going to increase the surface area because there's going to be an extra surface exposed. If you follow this on, if you were to grind it into a fine powder, you'd have much more surface area exposed, therefore more reactions are going to occur, and the reaction is going to occur faster. Another way to increase the speed of reaction is through the addition of catalysts. And catalysts are a molecule that increases the speed of reaction without undergoing a permanent change and without being used up in the reaction. For this reason, you only need a small amount of catalyst for a reaction to occur, because this catalyst can be used over and over again in many different reactions. And to show that this catalyst is not used up as part of the reaction, so it is not a reactant or a product, we write the catalyst over top of the arrow in our equation. Now, an enzyme is the special name that we use for a biological catalyst, so a naturally occurring catalyst in a biological system. And an example of an enzyme that you should be familiar with is chlorophyll. Chlorophyll is used in the photosynthesis reaction, where carbon dioxide reacts with water to form glucose and oxygen. Now, if you got some water and some carbon dioxide in a test tube and shook it up, they're not going to react. We're not going to have glucose and oxygen form from that. We're going to have the chlorophyll there as the enzyme or the catalyst that allows that reaction to occur. So we write the chlorophyll above the arrow. And we also need the energy from the sun as another catalyst for this reaction. And that's why we write chlorophyll and sunlight on the arrow rather than in the reactants or the products. In this video, we've looked at energy, and in particular releasing energy to the environment, being an exothermic reaction, or absorbing energy from the environment as in an endothermic reaction. We've looked at how increasing temperature increases the speed of reaction, increasing surface area increases the speed of reaction, and the addition of catalysts, or the biological catalysts, enzymes, also increases the speed of reaction.